should start anytime. Okay, the recording has started. So, okay. So, good evening, everybody. I am Afolabi because I'm seeing some new faces in Miss Onyiye. So, good evening, everybody. I'm Afolabi, been your tutor post Princess era. And today is going to be our semi-last class. So, we'll be talking about our last topic today. Our next class, which is the next week, will be in the middle of the week. We're going to be talking about everything blends throughout the entirety of classes. Classes are correct. Throughout the entirety of the curriculum or whatever we might want to call it. So today's topic is going to be about motions. So working with the motor and everything like that. And since I have no solid lesson plan, we just have to go at have to go at it together. So uh first of all, I usually start with theory. So I love theory, and it's very important to know what makes up uh motors and how you can actually use them in your projects. Now, the topic or sorry, the topic we're supposed to deal with this week was supposed to be motor theory and fundamentals. So, but I'll take a spin on it and do more of motion, the way motor works, and all those kind of things like that. So I'm very sorry for not having a class yesterday. I was busy. I was in a meeting and everything like that. I'm not even supposed to have one today, but I just decided that I already promised you guys, and we're going to have it today. So today we're going to be controlling motion. So up until now, we've dealt with a lot of things. We've dealt with sensors, sense the word sensors, displayed information of screens. For those that even if they couldn't attend, they were able to watch the recordings, you've seen, you've practiced and everything like that. So now we want to make things move. So that's what we want to do now. So now this what we want to do here is robotics, is little of automation, and it's the like foundation, like fundamental of every machine around you. So there's always going to be movement. Movement is always going to be done through motors. So they are developing new ways, but that's not for us right now. What we're going to be dealing with is motors. And as usual, if you don't understand me, feel free to call my attention. I'll go back. And again, if I'm speaking too fast, you have a question, just signify. I will always go back and retouch on that particular aspect I spoke about. Lackner. So, any questions up until now? Anyone? Okay, no questions. So, before we continue, in my usual habits, a summary of what we dealt with last week. I know people that were in the last class that are currently in this call with us, on this call with us. The two Israels. Any summary you want to give us, any achievements you made throughout the past week, give practice and everything like that. Because I know I haven't given you guys your assignments. I'm going to double down and make your assignment more difficult with this new topic I want to teach today. Is the man is ready? Anything you want to mention about our last class? You like call names? I like responses in my class. That so. Do I take that
Well,
as Yeah,
good evening. I think
I'm with you.
so. Last week we talked about liquid crystal display (LCD).
Yes.
So that's what you show us the. Oh, you talked about the theory actually. About
Yes.
I think you talked about the bus and and the 8 memory address that we have, if I remember.
Yes.
Yeah. So one is to read to the listing and write, read and write memory, something like that. And it shows the
Okay.
setup and the code. But I've not been able to practice actually due to school activities and busy and also. That's the little I remember.
Okay. That's at least you remember something. Remember something. Which is very nice. Like very, very nice. I'm going to give you half mark. So it's not worthy of a prize, but at least it's something. So last week talked about LCDs. So talked about how LCDs work, the different types of memory LCDs are. The I2C communication method that the LCD uses, R16 traditional 16-bit LCDs worked. We talked about the different types of memories in LCDs, how to create your own custom characters. What else we talked about? Yeah, talked about the addresses, 8-bit addresses, the read write address, the way the addresses have been calculated, how they've been converted from binary to signal address, just different things. But that's mainly we discussed mainly about LCDs and also did it practical. So everybody, I made sure everybody was involved. Worked on LCDs, also do multi-screen LCDs, um, schooling text. Worked on that also. How to convert signals from your other sensors and display it on LCD. We talked on that. And also, as for not the least, I showed you how to write code, C++ code, with Arduino, everything in relation to your LCD. So since that has gone by, if you don't really remember, I don't think I will have time to touch upon it. So you can always go ahead and check the recording of the previous class. So now, first things first. On yes, do you want to say something?
No, I don't want to say something. My phone is misbehaving. Sorry.
Okay, no problem. No problem. So, let's get to today's topic. Motors or motors, whatever English that you are used to. So, we all know what motors are, and I'm sure one way or the other, we've worked with it. You've not worked with it. I might not make professionally in time of an Arduino, but all those cool little fun little projects you make when you're young, you make your own car, make something like a fan or something like that with motors and everything like that. So it is this traditional name we call it when we are young, call it rotor. So I'm sure one way or the other, you might have seen it or worked with it. Those are small 5 volts that work with a 9.2 volt battery. So that out of the way, we all know what a motor is. So, and what I'm going to do is explain how a motor works. So, a motor, or every single motor that has been created in this, I don't want to say universe, but on this earth, follow the same principle, whether big or small. Electromagnetic force. When current flows through a wire in a magnetic field, the wire experiences a force. Now that wrap that wire into a coil, put it on a shaft, and you have a motor. Simple as that. So what happens is motors convert the electrical energy they get into mechanical energy using the same principle that a generator uses. It's just that they're the opposite of a generator. So if you can rewire a motor by reversing the chain, that's electrical to mechanical of a motor, and rewire it and reverse it to mechanical to electrical, you get a generator. It's actually the same device, like same principle, same everything, just each working in reverse tandem. Is that clear? So now, okay, come in. Just want to. Okay, I think I've admitted this person in. Okay, so okay, yes, person has joined. So, Stephanie, could I won't be able to really, I won't really be able to touch up too much on what I've discussed earlier, but we are going to be looking at, what do you call it, motors today. So, as I was explaining earlier, generators, motors, same machine, same principles, just working in reverse tandems of each other. So now we know the general idea of a motor works. So now we have to do a comparison on the different types of. So two main types of motors are stepper motors and the DC motor. So I want to do something coming down to get you guys a picture so that you'll be able to understand what I'm trying to like talk on and focus. Come in, let me get you the picture. Sorry, I'm just trying to get a picture so you guys won't feel lost. Okay, good. Let me see on the screen. Okay, you can all see my screen, right? So different types, two different types of motors. We have the stepper motors and we have the DC motors. So now the differences between both are features. So as you can see, first one is the control type. So for a stepper motor, the control type is position, while for DC motor is speed. So what that means is the way these two motors are actually is it where I want to use. I'm trying to look for English that will match what I'm trying to explain. Okay, let's say the okay, the advantage, yes, the advantage that the stepper has and the speeders in terms of control, that's what kind of control did they give you is between position and speed. Position in terms of where you can put it, flexibility, rotational movement, and speed in terms of just pure raw speed. Is that clear? I should explain again. Is that clear? Okay, I think that is clear. So now, stepper motors are they move exactly 500 degrees or 500 steps clockwise. It does exactly that. Why speed controls are so DC motors are speed controlled, just speed advantage. So you say, okay, but 50% speed, over 100% speed, over 25% speed, it does that. So the other the other difference is precision. So it still boils down back to this explanation I made earlier. So a stepper motor has like 200 steps per revolution. That's the typical steps. Could be more, could be less, depending on the kind you get, what version or whatever. Also with this configuration, but basically about 200 steps per revolution. And for those that don't mean, a revolution is completing, making a complete circle, and how many steps, and the revolution is. So that's let's see, 200 steps. That's 1.8 degree per step. That is that's the degree movement for the 200 steps per revolution. You know, revolution is that's 360 divided by 200. That's 1.8. That's 1.8 degrees per step. So that means you can position through. Why for DC motors, they spin continuously. You can't they spin several times per second. That's several revolution. You can't really control how many how fast they spin. So now another difference is speed. Fast, like very fast, thousands of RPM, that's revolutions per minute. While stepper motors are slower, typically between 0 to, I think, 500,000, correct me if I'm wrong, 500 to 1,000 RPM maximum. So, but steppers can hold position even when stopped. So, now, torque. So, I don't know, pronunciation might be different depending on what kind of English you speak. But torque, the stepper motor shall usually have high holding torque, meaning that they can resist being moved even when stationary. That's since they can hold their positions when you try to jerk the motor, you can resist being moved. While DC motors move at high torque because they're constantly spinning at a very rapid. There's always going to be vibration, there's always going to be movement and everything like that. So they have high torque when spinning, but none when moved because there's no energy conversion, there's no spinning, there's no movement of speed and cost is another difference. Stepper costs more. The DC costs less than a stepper. Driver needed. For a stepper, you need driver. But it's not in all cases. So there are ways you can configure it without the use of a driver. And the use cases for stepper, 3D printers, CNC machines, cameras. So for DC motors, we have pan, wheels, and RC cars. Any question at this point? Any question, please? Okay, yes. So Miss Princess have a question. Please go ahead and ask.
No, that was a mistake. I meant no, we don't have any question.
Yes. Uh, let's get right into it. I also want to get another picture for you. So that's going to make what I want to explain next understandable. So, uh, is here any? You just have to try your best and forgive me because I'm supposed to be in a meeting right now and they're just spamming me messages. So, yeah, let's get done. So, yeah, let me. I want to change the screen. So now want to talk about what I want to talk about next is actually how the motors, stepper motor to be exact, actually work. So now, stepper motor, the way it is unipolar. That's the how do I want to explain it. So the rotor is whatever this is in center, and the magnet positions are always permanent. That's four coils, coil A, coil B, coil C, coil D, and the magnet are permanent. Stationary magnets don't move. So what we do is to make, so now since we have all this, to make listen, to make it turn, like to make the motor turn, we energize the coils in sequence. So when we energize A and B, the magnet and the rotor is pulled that way. When you energize B and C, rotor and uh, the rotor rotates at 90 degrees. When you do C and D, does another 90. What? Contrary to like the other 90. So if you're starting at a position, it's going to do 190, another 90, that's making it 180. The other D and A is going to make it 360. So it's sorry, like 90, 90, 90, 90, 90, 90, 90. If you get 190, 290, 390, 190, that's 360. We talked about 300 and, no, sorry, 200 steps in a singular revolution. That's 1.8 degree per step. You understand? If you don't understand, let me know so I'll explain. Uh, I don't see any answer. I take that as if people understand it. Okay. So now, cannot for a step up, but there are different types of step. So we have the full step. That's 4 steps per cycle. So what happens is, since we are moving at 1.8 degree per step, so for a 200 step motor, each cycle is moving at 4 steps each. So it's simple, but it's less smooth because it's going to be creating this kind of jaggery, other things like that. So it's like when you say, watching something at 40 frames per second instead of 60 frames. So it's simple to run at 40 frames, but because it's less frames, it's not going to be very smooth. So it's the exact same thing with a full step. Because you're using 4 steps per cycle at 1.8 degree per step sequence for a 200 step motor. It's going to be like it's very simple to execute, but it's going to be less smooth. We have half step, that is 8 steps per cycle. So that's 0.9 degrees per step. That's smoother because it's covering the small steps are covering a smaller angle to the revolution. That's smoother, but double the precision because you're cutting down the window that is flying over by uh, from 1.8 to 0.9 degree per step. Now, the last but not the least type of stepping is micro stepping. So what this is you subdivide each steps into smaller increments. That's 1/16 micro stepping. So that's going to be 320 steps per revolution. So this is ultra smooth, like maximum smooth. It's like when you're watching movie 4K 320 FPS type of shit. So that's the way it is. But there's always a big caveat, and that's control. So when I'm trying to do that, it needs a very much advanced driver to actually control the thing you to get that level of precision you're actually looking for. Any questions? Any questions? Yeah, I think that has no questions. So let's keep go here. So now, so now, one question you might be asking, okay, why do you actually need a driver for a stepper motor? So first things first, a stepper motor has between 4 to 6 wires, depending on the kind of stepper motor you are getting, and you need to switch currents through those different combinations very quite rapidly, as it's B, C to D, D to A, all those kind of things. So now an Arduino pin, also not an because it's not a single pin. Arduino pins cannot actually provide enough current to actually reach that level. Is speed. I'm gonna put it, yes, speed and accuracy you're actually looking for, because I think Arduino pins provide 40 milliamps maximum per pin. If I'm right, is it milliamps? Yes, it should be 40 milliamps. I'm going to check. So it should be 40 milliamps. So that's the maximum they provide per pin. So, and manually controlling the sequence by code is very complex. So an example is going to be the motor driver IC, like the ULN 2003 or the A4988. So what that motor driver IC does is it's handle current amplification. For those that don't know what current amplification is, that's increment of, and it also handles proper switching sequence, control, and section circuitry. So come on, let me add this person. Let's commas. Okay, so now talk about oh, come on, let's come so okay. So for Daniel and Promise that are just joining us, talked about a lot of things and we have to go back. So I beg you, please go and watch the recording. So now, what about the stepper motor? Now, talking about the DC motor. Let's make another picture for you people. Let me know. Okay. Sorry, I'm trying to get it from. Okay, I think I've gotten it. Okay, so then we have this DC motor. So now, so this is the side view of the DC motor, right? And for those that done do mechanical engineering, this is going to be something that is not relatively new to us. So we have the permanent magnets, not on south poles around. That's the ones that are always at the end. Let's see. Uh, image. So, cutting on that side by side. It's not that clear. Sorry, I'm trying to like get another image. Okay, come on now. Okay, you can also win, right? This out the way. Okay, so leaving all the more complicated diagrams out of it. So we want to talk about permanent magnets. So that should be around, let's see, this is our brush. That's brush for left and right. That's this should be the left, right. So this has more than so because this one is a more advanced motor, but same principles, positive, negative. So then we have permanent magnets around there, inside there, just around there, as you can see. That's a permanent magnet, our north and our south poles. Then we have the rotor itself. This is a big round of coil that is our rotor. So the brush points power, so right power to the coils. The coils do some electromagnetism and start spinning because of, you know, general principle I explained earlier. Starts spinning that drives the gear. So when it starts spinning, uh, 5 volt DC motors will have a pin that you can connect whatever you want to connect to, but this is a more advanced uh, contraption. So this one is the gear and other things that I don't want to know what it's about. So, but you get the point, right? So this is like, I think I should have a side view, but it's still the exact same thing. A magnet, permanent magnet, a brush at the end, the rotor, funny little coil looking rotor, and the exact same principles. So now DC motors are simpler conceptually. So what it does is you apply voltage, those spins, reverse polarity, reverses, increase voltage, faster spin, power, causes it to stop. Simple as that. Now, the way control speed is done through a PWM. So I think I've explained what the PWM is in this class. Who can still remember what the PWM is? Anybody, I mean, anybody. Uh,
Pulse width modulator.
yes,
I
pulse
think that
modulator modulation. So that is correct. So that is what a PWM is, and that's what you use to control speed in a DC motor. Unlike, you see that this is even, I think I should look for should look for this thing, picture of a stepper motor. It's not going to feel like I just showed you a proper diagram. Step 2. Okay. So I think I need circuit image of the Oh, this was oh, get up and just hit search. Okay, let's see. Think. Okay, so take this picture, would do it. Yes. Okay, yes, this do it. So we have our course. If you remember that the previous image I showed you, I think this is more coils than what I showed you before, but still the exact same thing. Two, 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 two. That's four directional movement. So the magnet will always be in the center, as always. Then power is being controlled and everything like that. So, Lachlan, any questions? Any questions, please?
Please, can
Question.
you come,
Question. Please, can you repeat your question?
can you come again? You were trying to explain with, I think, one of the diagrams. Can you come again with that?
Okay. So let me see. Oh, yes. Okay, let's do this. This needs to be better. So let it load. So it's like in the meantime, okay, yes, this is it. So if you remember the diagram I showed you, come in. I think I haven't closed it. See here. No. Well, it seems like the diagram was closed. But in the diagram I showed you about the internal workings of the stepper motor. Unlike these that has 6 cores, right? 6 cores. The one I showed you had 4 cores. That's like you can see older version of some sorts. So now in the explanation I made mention of the cores being at the outer ring, then we have a permanent magnet in the center, right? If you actually did listen. So I did make mention of that, and even in the diagram, that was the exact same thing that was there. So it's the exact same thing that is here of motors. So this gear is one that enables the rotation because you know each coil controls different thing. What that means is these 2 coils right here can maybe control it to move like controls 90 degrees, 90 degrees, 90 degrees, 90 degrees, as we've explained. So that means that I think this is 1, 2, 3, 4. Yes, that's 4. You see the exact same 4, but this one is just 2 coils instead of 1. So that means this is a 90 degree. If we full step, that's going to be 1.8 degrees for it. Yes, 1.8 degrees. So, but that's going to be 90 degrees on these two, 90 degrees on these two, 90 degrees on these two, and 90 degrees on these two. What do you get what I'm trying to say from the explanation? It's always a center magnet. The coils is the one that controls it. So the coils being controlling it are the ones that give it the exact position that the stepper has over the DC motor, because this just a single coil that just spins like it. It's, this is yes, this just has a simple coil that just spins up like this. Exactly. Okay. Okay, it's clear. So now what I wanted to explain next was PW and how we control speed in a speed motor. So yeah, in a speed motor. Same thing. So now, if you remember in the way I explained PWM, PWM controls using. Think I don't have the picture here. Oh, I don't know. I'll put it. PWM modes. I think. If you remember, if you remember, should be footage line with with this kind of zigzag with the 40 milliseconds and other things like that. I also explained it in the last class with the way the LCD and the everything works, the SDA and SDA line works and everything like that. So more information about the previous classes, videos, recordings to be exact. But in relation to speed control, in an 100% duty cycle, that's always on. That's the full vote. So what happens is the PWM or the Arduino supplies full power to this to the DC motor, meaning that getting full speed ahead. While for 50% duty cycle is the PWM. The Arduino uses a PWM to send about 2.5 volts. That's like cut out volts. So that's half the speed. Then same thing with the 25%. That's 1.25 volts. That's called out the speed. It's also like that for the 75%, and just for general. And one thing to know is the frequency of the change is at 490 hertz. That's the Arduino default. And the motor sees the average voltage that the Arduino sends due to inertia, and that's due to speed. So the motor can react to individual pulses at 190 hertz because that's going to be too fast. So what the motor does is it responds to the average voltage. So by varying the duty cycle, that's we can control the speed smoothly. Now, what I want to explain now is why do we? No, sorry, I almost crossed there. So why do we need an H bridge? So for those that don't know, H bridge or a H bridge is kind of circuit that is created. It's one. Let's see. I think I should be able to choose. Don't just see. I just. Sorry. Okay, so H bridge is something kind of like this. Why is it not drawing now again? This thing, you have to draw on this picture. Okay, so H bridge is kind of like this. Then like this and like this. So we have our motor or our motor in the center right here. Then we have our switch 1, switch 2, switch 3, and we have our switch 4. So that's basically what an H bridge is. It's just like a kind of connection. So why we use an H bridge is for control. So for DC motor, that's the one that moves with speed without sense. Yes, there's no way you can give absolute positional control the same way you can do for a stepper motor. So the way we execute control is using reverse polarity and rest. And you can't say, oh, let me reverse polarity. Let's reverse this motor. You go to your Arduino, unplug the wires, and reverse it. No, you can't do that. So that's going to be extremely dumb. So what we do is we create an H bridge. So forward is going to be switch 1 and switch 4 on. Reverse is going to be switch 2 and switch 3 on. And break is going to be switch 1 and switch 2 on, or switch 3 and switch 4 on. And all of that's coast still going to be all switched on and off. So now, to reverse a DC motor, what we need to do is we need to reverse current direction. That's the way the current is moving into the rotor. So if it's moving in this direction because of this as the positive charge and this as negative. To reverse, we have to reverse it. So that means this is going to be positive. This that is negative before, it's going to be positive. And this one is this thing. And this one that is positive is going to become a negative. You understand? Any questions up to this point? Please don't mind my weird drawing. Well, any questions? Okay, no questions. No questions. So now the H bridge uses 4 switches. And the switches in our case are going to be transistors to control current flow between both directions. Now, because the Arduino pins cannot, number one, provide enough current, motors need about 0.5 to 2 amps to work to function correctly. Arduino pins cannot provide kind of voltage, and Arduino pins can't also undo voltage. That's some motors may need between 6 to 12 volts, and Arduino pins cannot reverse polarity. That's another thing. Arduino pins cannot reverse polarity. So what do? We use a driver along with our H bridge. So the L298N driver, motor driver that we use today contains an H bridge with, that's what it contains. So along with the H bridge contains a current capacity of 2 amps per motor, a voltage range of between 5 and 35, and built-in flyback diodes. That's it. That protects the motor. Sorry, that protects from motor back EMF, and heat sink that it dissipates heat from switching. Okay, yes, Miss Onye.
So you're speaking too fast. Can you go back small? You have lost us. You lost me.
Okay, okay. I'm going to explain. So
Bye.
now
Okay.
I'm going to start. I'm going to start from the beginning. Don't worry. So H bridge, this ugly bridge right here, is needed to enable DC motors work correctly. Now, the motors or motor is going to be the one at the center where we have 4 switch 1, switch 2, switch 3, and switch 4. Now, what the functions of the switch is to control current flow in both directions. Because in a normal, if you connect motor to a normal Arduino pin and everything like that, like that's magically without using the transistors and everything, and let's say surprisingly works, it's going to be able to move in only one direction. That's the plus and the minus. That's one rotation, one direction, moving clockwise. Now, if we want the motor to move counterclockwise, we have to do the exact opposite. That's we have to reverse the polarity. That means this plus will connect it to minus, and this minus will connect it to plus. And because you can't do that using an Arduino pin, that's one of the reasons why we are using H bridge, right? But that's one of the reasons why we're using this Madam H right here. Now, Madam H contains 4 switches. What we now do is we map different switches to different things. So if we turn on switch 1 and switch 4, 1 the polarity, we get on. If we do that, we get on and moves clockwise, that's forward. Now if we do 2 and 3, we get another on, but this time it moves counterclockwise. So that's forward, backward, clockwise, and counter. Sorry, mind my rubbish. I'm handwriting. That's counter clockwise. So that's the thing. We have a clockwise, we have the counterclockwise. Now, the reason why we are now using this entire Madam H in the first place is what I was explaining. The things the Arduino pins can do. Can do three things. Can reverse polarity, can provide enough current for that the motor needs to run, can provide enough current that the motors need to run, and uh, and also what it can do is it can't reverse polarity. Now, Miss Onye, your hand is raised up.
Yes, like I wanted to ask, is it preset? Like the one that allows
Uh,
like the forward and the reverse, is it preset or is it according to the one you choose?
so uh, so I can't really give an exact answer because sometimes when we preset, we might have to set it manually. Just depends on what you are doing. And if you want to build the H bridge manually, do it. And if you are using a pre-built H bridge, same thing.
Okay.
So now, a driver that we use today, for if you that want to use a pre-built H bridge, a driver that we use today that contains an H bridge is L298N motor driver. So, and the H bridge it contains the following. That's a current capacity. That's a current capacity. That's a current capacity it can handle. That's 2 amps per motor and a voltage range of between 5 and 35 volts and built-in flyback diodes that protect from motor fallback EMF and heat sink that dissipates heat from switching. Because the switching or the switches that we're going to be using are transistors, and transistors get very hot. So we need heat sink so dissipate heat. Now you might be wondering, what is a back EM5, a motor back EM5? So what that means is when the motor stops, it acts like a generator briefly. That's, you know, reverse type shit and everything like that. So what it does is it produces a voltage spike. That voltage spike is what we call back EMF. That's when instead of the Arduino to be sending power, the power is getting sent back to the Arduino. So that's back EMF. So this can damage Arduino pins. And motor drivers include protection diodes to absorb these spikes. So never, and I repeat, never connect a motor directly to Arduino pins without proper driver or protection. Well, if you are someone like Princess of God that is very rich, you can do it because you can always afford more Adrenos and more motors and more whatever components you might want to drive that particular day. So now we're going to be moving to Tinkercad. I think we've done enough theory. That's an hour of theory. We want to do practical. So today's practical is going to be, I'm doing it along with you guys because I couldn't prepare. Still supposed to even be in a meeting right now. So let's get the close of this and get everything wired up. So set everything on ground. That's okay. Comment, close all this. Okay. So we're going to be creating new circuits. Let me share my screen. I'm going to bring this together. Okay. Oh. New circuit. Now, let's see load. Okay, so I'm going to start with, let me reduce the file of just whatever this is. Okay, so first things first, we need a stepper motor. So let's just stepper. I'm not even sure if it's here. Oh, so it's like we don't have a stepper motor here. See, it's the I think the Y Z G or G. I think this is wrong. So it's G Y J. Yeah, we don't have a stepper motor in here. It's quite bad. But let's see if we have a driver ULN 2003. We still don't have a driver that we use for stepper motors. So we'll skip that. So we have to skip that. So we have to go to DC control. So we should have a DC driver in L2. L2 8. Oh, we don't have the one we have is different, quite different. So this is L293D. So I don't think we don't have 98 that I'm looking for. But we'll walk along with this. So then we get a motto. Well, it's gonna be kind of complicated to work with this. Yeah, but well, nothing is impossible for God, sha. So let's get a motto. Okay, so I think we'll use two motors. So okay, then we need the batteries. We'll see if there's any starter connect that can get us started with something. They have nothing of use. So okay. So without this, we'll just need the basic Arduino. Let's get this. Mm, 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 mm. Okay, then a battery. Let's not forget another battery. Okay, so it's even native. Now let's start connecting. Okay, so our this to our Arduino, what we want to do is connect the ENA to pin 5. Okay, this ENA, it will be pin 5. Then we're going to connect our ENP. Okay, let's do this. So then input one, input one go to pin 7. So I'm sorry that you might not get any explanation like previous classes. So I've not really done this to, let's say, practice or something like that. So this is also my first time doing it. So I'm expecting things to go wrong. So just like want to first sort out all the connections needed first. So this will go to page 6. Then Q3 to 4. 3 should be. Why did Q3 go to that? One, one, one. Input one. Don't stress my life. So this is going to be 4. Then I read later. Then input 4 is going to pin 3. Two. Sorry. Input 3 is actually going to pin 4. Sha. Two. Am I even right? Yes. Oh, good the future. Just going to pin 3. Ah, this is a debugger's nightmare. Okay. Then so I think putting okay, one more thing. One of the many useless grounds we connected to print output. Then what we do is get another ground to a 9-volt battery. So I think what's this output to this output to, I guess, to take this motor wire 2 and motor wire 1 connects to output 1 should be here. Output 1. So okay, output 4 connects to yes. See, so sorry about the confusing wire configuration. Everybody's just sorting everything out. Okay, we need a 12-volt power connector. Going to be from our power 1. go all the way to our battery. Then I think that will be all. Thank you. No, I'm not sure. Uh, I believe that's all. But we can't be social until we test it out ourselves. Okay. Now, let's do the next best thing. Start writing the code. Okay, I don't think I've written code with you guys before in class. So, okay, let's the main. Start right. Comment or to A. Plus, if you think photo A is in my case, is a left photo. So, uh, so, so what I want to do now is I want to declare the want to create constants that will determine where and where our kidney are connected to, what pins our what they call it, the different things are connected to. So okay, I can say for our motto A, we declare a constant. For those that have been attending class, I've said a constant is a variable that throughout the entirety of the entire code, it won't change. So that's constant and then motto A underscore, let's call it impute 1. That will be equals to 7 because it's pin 7 that it was connected to. Yes, no. Impute 1, yes, impute 1, 7. So the exact same thing. And let's not forget that semicolon. The same thing 3 times. Sorry. So this time it's going to be impute 2 and just control that's ENA. ENA. We have 7. Oh, did the wrong thing. Okay, 2, that's 6, and that is a 3. Now that's this 3. Is it 3? No, it's 5. Oh, wait, 5 goes where? Oh, yes, any one. That's 5. That's our PWM pin. Then do the exact same thing. Copy everything and give some space. Do it, but this time change it for B. That's going to be our right motor. It's motor. Q3, Q4. This is going to be E and B. That's going to be 4, 3, 2. It's the same thing. Oh, then let's not forget. Change this to a B. Another B. Nice. Okay, so the next thing to do is to our main variable set up and start with our serial. That's to activate our serial monitor. Serial begin, just start it up. Oh, I was forgetting something. What's it's been doing it like this now? Okay, so at the begin, that's the start of time, milliseconds, bit semicolon, then comments to show what you're doing. So it sets uh nonsense. Set of pins as page. How do you do that? Running pin inward, printed sys, that's more to a underscore one. Set it to output. No, and parentheses. Control C. The same thing twice. Okay, rotate 3 times. Times. So this is going to be 2. Select a comma. What did I do? Oh, it's correct. Did I just do just put myself in stress? Competences, then this change it to N A. But this is really stressful. Just with writing this thing out on some for be something. Hmm. No. Yeah. Okay, I think that's correct. It don't. Yeah, it is. Then so mm, this this will make it side. This thing today. Then close it. Then we now write a loop. Now, God. Now, sorry, I just want to start writing the loop. Okay, okay. Space. Oh, commentary. Anyone objecting? So to the exact same thing, but this time for different part of the code. Just paste this thing to backward. Then you change this thing to backward also. Another mistake. Oh, then I have to change it to 255. So I think for now, so I'm not going to write so much code. I'm just going to like leave it at this. So let's first test this out before we can even try anything, because I'm already even tired of writing code right now. Start simulation. What oh, I made a mistake. So right here, supposed to be B, where I put A. Come on. Close. B. B. Just if you guys remember, it was B that was declared. So let's write again. This is missing again. Move forward was not declared in scope. Oh, well, I did not declare it. I forgot. We are trying to use functions that don't exist. That's why it's not working. So we have to declare those functions. And do we do it? We do it by writing the code to declare those functions. So what do we do? Start by going another line. I don't know why this is going to the center of this place. Okay.
Hello, sir.
Yeah.
I think it not close the quotation stuff for the forward full speed and the backward speed, the print line.
Oh, that's another mistake. Thank you. I didn't see that also. So thank you. Now we have to call our functions. Okay, so for our function to move our motors forward. I wish I had done this before class. We have to create a function of move forward. And in speed. So this is god, this is started again. I don't know what's wrong with this thing. It's not supposed to be this much arbitrary. Okay, so first variable declared. So normally I'm supposed to put comments, but I'm really too tired to put comments. So I'm just going to like this digital. That will be digital dot digital right. Then do for moto A, moto A underscore A1 GH close brackets this to digital right. Same thing again. Bracket moto A and okay. So below. Going to explain what I'm doing in a minute, but let me just write the code. This is why I usually write the code before class because it takes time. It's quite annoying to write. Just look at that. Let's go that's ENA speed just declared function and this. Then I'll do the same thing for moto B. Quite annoyed, but on a normal day, I'm supposed to like put comment, but I don't think there's time for comments because it's pretty getting late and I've not really gone so far in class. The class digital, right? Then same thing moto B plus IN3 hyphen I close parentheses, maybe two I's, close parentheses. So same thing, digital right, parentheses moto B underscore IN4. Potential that's going to be low. Then close parentheses, semicolon, then analog. Okay, so analog, right? That's going to be more. So B underscore. That's going to be ENB. Yes. Yeah, this is going to be speed. Okay, think close parentheses. And that's all for the move forward function. So we have to do the exact same thing for the move backward. The only difference is we're going to switch the I to low and the low to I because it's reversing of polarity. So I'll do this because I eat stress in my life. Control C, come down here, give it some thinking through. Space, Control V, it's all right. Then change this for take this and ESA. Oh, mistake. It's not just one word. We'll just write this first line. Move backward. Oh, another mistake. I forgot to see here. It's supposed to be int space speed. Oh fuck. Making mistakes on this is kind of deadly. This rate, don't think I'm ready for it. Why is this thing doing like this? It's kind of annoying. Okay, not backwarded. Looking for int speed. Close parentheses. Start this one. Then move this here, and what we have is this. So we have to do the exact same thing, but change this to low. Yes, low. Then change close parenthesis. Then this. Then do the exact same thing here. Change this to I. Close parenthesis. This. Then same thing here. Low. Close parenthesis. We have this. Then because it's reverse polarity that we're trying to work with. Yeah, that should be all. I think. Yeah, that should be all. Yeah, let's see if there are any mistakes. Not that I can see. Well, let's run this first. Oh, oh, another mistake. Why now? Did I offend? Oh, well, okay. Let's deal with the mistake. This, we forgot the parenthesis here. Then this with the slide variable. Two. Oh, I should write this thing. Row. Then I think it's so. Oh, and we're gonna be capital I pray that's all. Oh, that's not all. We got this. Okay, I pray that's all. Okay, let's run this one last time. Ah, so first of all, the code is correct. Second of all, our Arduino is fried, as you can see by this. So, and you can see from the problem, it says the total current passing through the IO pins is 255 milliamps, while the maximum is 200. That means it's saying something. What did he say? It says this will permanently damage the Arduino. Well, looks like I don't know if it's working. But it's saying 0 RPM. That means it's not working. So, well, our code is saying something stupid here. So there's going to be a problem with our connection somewhere. This is the worst part of doing something like this, debugging. So we stop our simulation, stop damage our Arduino. Then I'm going to look at the problem. This total current running through is 225. Maximum is 200. So that means I think there's a mistake in one of these connections. Am I missing something here? This ground, yes, ground. Both grounds are connected. Why do I feel like I'm missing something? Uh, I'm coming now. Coming. Trying to see what I'm missing. So I don't think I'm missing anything. I think the problem is this driver I'm using, this HP driver. So I think this version is not a L298, and I've never worked with this version before. This is a L293D. I should not lie for you, I've never heard of this model or even worked with it before. So what can I do? What can I do? What can I do? What can I do? It says maximum current going through the pins is 225. What might be the cause? That is not with our code here. who is working like a regular human being. Okay, I think it's this H bridge. We must be using the wrong say connection. Is there one that's missing somewhere? All connections look attached. Let's move this. It's one thing I do it doing. Say connected, then let's do the same. It's not moving. Is it? Oh god. Don't know why this is not moving now. It's all supposed to be fried now. When it's not that we're doing real life shit. Let's say connection. Okay, yeah. Connection. We can move that. I think we should be able to move this. Okay. All connections are accurate and securely attached. So what might be a problem? I have no fucking clue. But but okay. This summer pass passing through the pin, everything. So what if what if I try to ground it? Come in first. What's even this one run through? This should be second power. Let me try one ridiculous thing. I'm not supposed to try. No. What if the devil uses a particular human being and connects both powers? Let's see what will happen. Same thing. It's even more. Yes, the devil is supposed to use human being like that. I think I should try to ground this thing. Try to ground it and start it again. Well, we have problems again. Silo. Ah, God, Jesus Christ. So that means I'm coming. I seriously don't know what the problem is. I'm trying to even find the problem. I'm thinking, is see what I'm trying to do here, or do I try to? I'm coming first. Let's see if I try to delete this entire lineage. Go to the code and delete everything related to Moto2. Like just delete it. Delete it. Delete it. And delete it. So let's see what happens now. Do we still burn our Adreno? Oh, Jesus Christ. Apparently, we still burn our Adreno. Oh, E5. I didn't even see. Come first. Let's add it up in 5. Wait, oh, our ENA. So, what is our ENA doing? The ENA is currently running through 25. So, it seems like this is the H bridge then. So, I don't know if we can find any other different H bridge. Come in. Coming out, trying to like find something we can do. Let me just put this here so in case We can't get it working. We use this as practical. It's already connected. There's no any other H bridge. There's no other one. I think our card is fucked up, man. So I'm very sorry that this is looking confusing. It's actually what I go through because I've never actually used Tinkercad before having to teach you guys. So, and it seems like the H bridge I'm actually looking for, that's the L298N, is not available. And this, with the best of my knowledge, all my connections and everything, it's overloading our, what do you call it? Our Arduino pin. So a normal person might try to add this thing, a resistor. Should I try that? See no point, but let's see if that's let's put this thing to search for our resistor. If we try diode, no, let's try resistor first. So we'll try one by one on it to see which one actually works. So first of all, connect the resistor, carry it. I'm very sorry if you guys are confused because even myself, I'm confused. Well, let's just see the way we can undo this thing. Here's even 2 wires. From where to where? Leave this one. Leave this one. This to this to our E. Wait, oh Jesus Christ! Have I not made a mistake like this now? I'm looking at the wrong one now. It says D5. Picking the wrong thing. Wow. That means I'm coming first, please. In all my absolute foolishness, I think. Wow. So I actually did connect it wrongly. If what I'm saying here is correct. Come in. So this is D5. D5 is connected to input 1. D5 is supposed to be connected to our, what they call it? Our ENA. So that means input 1 is supposed to go to D7 that ENA was connected to before. Let's see if that is going to work. So let's get our ENA connected back again. Let's run our code. How is this thing still burning? My people, I'm as confused as you are, but let me see if that resistor trick will actually still work. Let's try it. So I have to believe and trust the process. Now, it's reduced. Let me see. The resistor did work. So let's try something bigger that can think and get it better. Let's see. Let's try diode. Sorry that I'm putting you guys through all this thing because supposed to regulate it. Not too much. It's even worse than the resistor. So let's see. Let's try polarized capacitors first. Oh, which one are we? It's so in terminal one. Ah, alas, we don't burn Bakini any longer. Our Adreno. So this is like a green flag, but this thing is not moving. I don't even know if it's moving or not. I doubt it's not moving. Yes, it's not moving. But our code is saying it's actually moving. So what seems to be the problem? Let's go and diagnose that issue. Yeah, I think this is what I'll do. Let's see. For all this goes to pay, what I'll do is, since this is saved, I'll come here like a regular person would. So sorry that I've wasted most of your time in showing you something that is not working. So just trying to get this thing to work. Okay, creating a circuit. So okay, creating a new circuit. What I want to now do is like battery. So I think it has started DC motor. Trying to see. Okay, so now this is just beer. Okay, you guys, I'm going to go and look at the other one I'm building later, but let's just use this to give you an example. So without our Arduino and everything, this is just a 9 volt battery connected to your DC motor, and we have a photoresist. So the photoresist is the one that acts like a controller, like a switch. So there's no any programmable unit, it's just direct connection. So when we start this motherfucker right here, when the light is small, the rotations per minute is 6, as you can see. And when we increase the light that the resist takes in increases and all the way to the limit that this rotor can take. This photoresist or the battery can provide it, which is 1973 revolutions per minute. So I think what's going to happen is this class we're going to hold it again because it's already 8 p.m. I'm very sorry that I couldn't get that sheet to work. So on a normal day I'll have done it and prepared it before class, but I wasn't able to do that today and spent more time debugging problems that we could actually not find. I'm very sorry. Hope you guys are forgiving me. Can I say thumbs up if you guys are forgiving me? Okay. Thank you. Thank you very much. So we'll still have another class next week because we're going to, and this time I'm going to be properly prepared because I'm supposed to even be in another meeting right now. So that's why I can really extend the class past 8 p.m. So I'll say we should just try and debug the issue together and see how you do debugging, solving of problems and everything like that. So you know that our Arduino is going burning, praise to Allah, but our motto is not spinning. I'll fix that. Maybe if I'll maybe what I'll do is I'll create another one, another class. Is it class? I'll call it. I'll create another project and I'll come and finish debugging that one next week. So intentionally, I'm not going to try to solve it. So solve it together in class next week. And next week is also going to be like our come together of everything that we've been taught throughout this entire throughout this entire work. Is it workshop I'll call it, or throughout this entire little process that I've been having all this while. So I'm sorry I won't be able to like. Do you guys have any questions for me? okay. I'll take that as 0 questions. So I'm sorry I'm able to ask questions this night and share prices and all, because I have to be out of here urgently. So thank you for attending, and I'll try my best to satisfy you next time. Very sorry. Thank you. Emma Vino. For those that understand Yoruba. For those that don't understand Yoruba, it means I'm very, 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 very truly sorry. Have a good night, everybody. Have an amazing week ahead of you. And I wish you good lucks in your exams and whatever things you might want to do. Thank you. You guys can leave. Thank you. Just want to end the recording.